Okay, so as like a little peek behind the curtain, this is what we're doing for overtakes. Strap in. So this is a routine that happens every time we get new data from iRacing, and the way my plugin is set up, it's slow. It's only happening 4 times a second. So we have 4 FPS of telemetry data. So it comes in for the first times, this track positions array might be uninitialized. So it goes through and it does that. Then once it's confident it's actually got a track positions array, we sort it first by car ID, because that's the way we get our telemetry data. One moment. Hello? Robot's calling me. Okay. So it sorts it by car ID. And then if they're in the pits, we set their distance to -1 and the lap to 0. And that drops them all the way to the bottom of the standings. And that's a key part of what I just put in. Otherwise, it puts in the lap distance percentage that we have for that car. So that just populates the array with all the updated lap distance percentages for everybody. And then we keep a copy of that array sorted by car IDX, because I use that all over the place, and it's easier to have it sorted by car IDX, and I can just look up by car ID. But computers are fast, so we can then just sort the array, and we do it by lap first, and then time, or the distance, the lap distance percentage. So now we've got the array sorted by lap distance percentage. And we want to look for uninitialized data and for undertakes first. So this does one whole run through the array, which is a little inefficient. I probably could compile all of this into just one loop through, but computers are fast, and this makes it easier to debug when stuff's not behaving as expected. So if they're new here, that means their position was -1 when they come in. So that just sets up initial values. They're, mostly -1s and stuff like that, but it gives them a position, and they have a track distance percentage. So if that's not the case, you check their old track distance percentage against the new one. So P is the index loop variable that's going through, and it's 0 based, but the positions are 1 based. So every time I have to do P plus 1 in these comparisons, which is a little awkward, but it's fine. So if the old position is less than the new position, that means it's an undertake. They got passed. So it checks this time value that I set when they are in that case. If it's 0, it means it just happened for the first time. So it sets that time, and it sets the position that I have to maintain the position they fell down from. So there's a down from value that gets the old position, and then they get assigned to the new position. And then for debugging, this is actually kind of fun. It's commented out right now, but I have it set so it'll switch the camera to watch that overtaken car. So when I'm debugging it, the camera's always switching to whoever just got passed. It's fun. So we do that entire loop for the array, looking for all the undertakes. And then we do another iteration through the entire array looking for overtakes this time. So if their old position was greater than their new position, that means that they overtook somebody to gain that. And we check to see if the time is 0, because if they're already in an overtake, we don't want to step on the every time through, we don't want to step on the old data. So this is the new killer feature part. So we get a lost position, which is searching the tracked positions array for the first time. We find anybody who has their position down from value. That's the target of what this car thinks they just got. So somebody must have lost that position. So that's what this lost position value comes out to be. And then we check to see if that lost position's track surface is either on track or off track, because those are the two valid cases. That means they're still on the racing surface, or they're on the thing, even though off track I want to see, like, if somebody goes off track, I want to see that pass. But if they're in the pits or they're out of the world or they're teleporting, those are all conditions that I don't want to see. So that's what gates this logic to say, okay, only in those conditions do we give them a new time and do we give them a position up from value. So and I had a little debug statement here to show when that was not happening. That's the closest I came to really testing this. So in any event, regardless of how that worked out, we give them the new position. So that's effectively looking for the overtakes. And then we check to see if they were in an overtake that's expired. So if their position uptime is greater than 0 and their the session time minus their position uptime is greater than this arbitrary threshold value that I have. I think it's 2 seconds. No, it's 3 seconds right now. So you need to maintain your overtake for 3 seconds for it to be considered. So if that's true, I check to make sure that they actually got a higher position than their position up from. So if they went up and down, but they ended up down, I'm not recording it. So maybe that's a little bit of a bug, and I should consider recording the marker anyway, just so we see that give and take battle. But for now, it's being a little bit more conservative, and it's only considering to set the marker if they actually kept the uptake. So then it's just got a few checks to make sure that we're actually in a valid session state, that we're racing, and that we're above the 0th lap, so the race is actually started. And then for every driver, I have a value that keeps track of, by car ID, whether they've just gotten a marker or not. So it's a little bit of a throttling mechanism. So as long as this comes back okay, that means it's been more than 5 seconds since the last time that car got a marker. And again, maybe I should take that out and just let them ride and get all the markers. But we're already getting hundreds per race. So if those conditions are met, then it makes an overtake event with all the data about the session number, the track position, the position uptime, the car ID, the lap they were in, the marker type that it was, the iRacing position and class position, and the lap. So all of that goes into an overtake event. It adds that marker. It writes out to the log that it happened. And then it updates that guy's session time so that it'll guard against him getting another marker anytime soon. So even if those conditions weren't met, we reset the values for the time and the uptime. And then this is something I have to check against the position time versus the current session time. If the marker time is ahead of the current time, it means I've been messing around in replay. So I actually want to clear those values out. So I just set it to 0. And then I don't know about the undertakes, whether we'll keep it or not, but for now it does pretty much the same logic to check for undertakes about, whether it's valid and everything, builds an event for the undertake, puts that in and stuff. So all of that is how we detect overtakes and protect against the phantom freebie overtakes because you pit or teleported or dropped out. And it should catch the cases like when somebody just Alt F4s and they're gone. So that is how it works. It's just that easy, right? Okay, so I wonder if the next Indy Pro race is going to go official. Let's take a look. Well, for me, a huge part of this whole exercise has been just relearning stuff that I did kind of know, at least philosophically, but maybe never put into practice. But like to do the whole marker replay overlay stuff, it's like there's C# code in my voice attack plugin that's running and checking all the telemetry data and stuff. So that's all C#. And when it finds a marker that it wants to play, it spits out an XML file through voice attack. So voice attack gets a message to do a command that writes out the XML file, but voice attack doesn't know anything about what's in the data. And that XML file appears on my hard drive. So I've got a IIS web server running on my computer with a JavaScript in an HTML page that's constantly using the AJAX HTTP request object to look for that XML file. When it gets one, then it hands it off to the HTML and updates all the fields in the table to display. So that's how we get from iRacing telemetry through my C# voice attack plugin, through voice attack to write the XML data, through the JavaScript and HTML to do the presentation of the visual page for the driver info overlay. I mean, it's almost self-explanatory, right?